A lot of what's...
I love your work. So.
Oh, thank you. You know...
You're live, so. All righty. It is my honor and pleasure to introduce our next speaker. I'm trying to say Michael at the same time. Michael Schneider. And I first found out about Michael when he wrote a book called Constructing the Universe. And I was so fascinated with him that I called him up and got him to come down. And we spent a day walking the beach.
It's great.
Just drawing symbols in the sand. And he's going to tell us about some of those symbols today. He has an excellent background, mathematician. He's teaching math now to art students. He's probably one of the few guys that can do it. And got all these fabulous degrees and things which you can read about in this book. But I'm just going to let you go here, Michael, and tell them some of the stuff we talked about last night, too, if you can. Just the...
Well, great. Okay, thanks very, very much, Walter, for inviting me, and thank you all for attending. I hope... Well, I'm really looking forward to all the rest of the speakers as well. Walter got us off to a great start, a lot to think about and a lot to ponder and continue researching. My name is Michael Schneider. I teach mathematics to art students. You might think that's sort of an anomaly, but it's a really wonderful thing because art students are very visual, and so I present the topic to them visually. There's no need for equations and graphs and formula in mathematics. I mean, it's very, very useful and necessary, but for art students, they enjoy the visuals and working with their hands and so forth. And so I hope to present to you something similar today, a visual presentation. I hope you enjoy Egyptian art. And so we'll take a little tour through a presentation that I call Golden Ratio Design in Egyptian Art, a Geometry of Regeneration. Now, what's interesting here, we see right away that this Egyptian image of a gentleman pouring some water upon a mummy and vegetation sprouts from it. This was a commonly done thing in Egyptian ritual. In fact, we see here a seed mummy. In fact, it was filled with wheat, and they would water it, and it would generate life. Life from death. Death, the mummy, and life, regeneration. The idea of fertility, generation, regeneration is common throughout the ancient world. Anywhere you look, there's great interest in fertility, generation, birth, regeneration. And it turns out that the geometry, the shaping principles that the Egyptians and others really around the world used to portray images of generation and regeneration use a particular geometry to shape them called the golden ratio. If you're not familiar with it, you'll become familiar with it today, because it makes a lot of symbolic sense to use a geometry that regenerates itself to portray generation and regeneration. There's great controversy about this right now among the Egyptologists and academics as to whether the golden ratio actually exists in Egyptian art, whether it was consciously used. Every once in a while, someone will come up with an example of a box or something that has this particular ratio in it. It's just the ratio that your elbow to wrist and wrist to hand make. It's found throughout the entire universe, as you'll see. But I think after what you see today, I hope that you'll agree with me that there's really no controversy. It's really quite obvious if you know how to look. I don't know why the archaeologists and anthropologists and Egyptologists and so forth don't see it. Maybe it's a poor mathematical education. Maybe it's they don't want to see it. But we'll see how this works. So let's see. Well, what do we know about Egyptian mathematics? What we do know generally is through mathematical papyri, and architectural papyri. For example, this one called the Rind papyrus, or sometimes called Akhmes papyrus. There are the Moscow papyrus, or Eisner papyrus, others and others. This Rind papyrus, named after the gentleman who purchased it, is dated to about 1680 BC, and it's known to be a copy of an older document, much older document. As you can see here, there are triangles and some other geometrical figures, and the Rind and other papyri are very practical oriented. In other words, how to solve for weights and measures, tables for calculation, how to distribute goods in a fair manner, finding the volumes of pyramids, jars, baskets, and they certainly knew the formula for finding the volume of a truncated pyramid, for example. They figured out this particular formula. So their mathematics was quite practical. That we can be sure of. In fact, modern computers calculate the same way that the Egyptians did, in base 2 or binary, without a multiplication table. Now, when I was in 3rd grade, nobody told me that you could multiply without a multiplication table. It would have saved a lot of people a lot of grief. But computers can't afford to use a multiplication table. It would slow down every calculation if it had to look up, what's 7 times 8 and so forth. But they had a very simple method that if you could double a number and you can add 2 numbers together, you could multiply. Very, very simple. Now, the actual title, we named this after Mr. Rind, who purchased it, but the actual title of this document is more interesting, and it gives us an insight into Egyptian perception of mathematics. This document was called Accurate Reckoning of Entering into Things, Knowledge of Existing Things, and Knowledge of All Obscure Secrets. That would make a more interesting math book than the normal Houghton Mifflin 3rd grade reader and so forth. Now, it turns out actually that all of Egyptian philosophy, religion, and so forth is based on mathematics, believe it or not. Their word, ma'a, which we see here as a glyph, which is the side end of a ruler, as you can see. It signifies truth. It's translated as truth. And righteousness, right measure, harmonious proportion, correctness, the harmony of the beautiful universe, and aligning with ma'ah, aligning with truth, the truth of life facts, eternal truths. There are capital T truths and small t truths. The small t truth is, I'm wearing a yellow shirt. That's true, but it won't be true tomorrow. The eternal truths are those found where everybody agrees, believe it or not. That's in mathematics, that's in the proportions of a vibrating string that produces music. These don't change, and so they base their civilization on these unchanging truths. We can see here a ruler, and in fact, the ruler, divided into 28 sections, tells a story. Each of the units is associated with a different god or goddess. And you can find out about that pretty easily. Here's a view of the entire ruler. And with this ma'a glyph, you can actually see it in their art. For example, here we have Ptah, the deity of craftsmen. He stands bound up, only his hands are able to move, and he stands upon the ma'a glyph, which indicates that he's bound to work in accordance with the cosmic order, with the truth of things. In ancient Egypt, they would never, and around the world really, they would never design anything that wasn't based on eternal truths. It would be considered temporary and false. So they designed everything to be in accord with the cosmic order. And for example, you can read some Egyptian imagery by noticing that very often deities will stand upon or sit upon the ma'a glyph. We see here a gentleman, Ani, is presenting his heart to the four sons of Horus who sit upon this glyph. We have supplicants who are coming to Osiris, green-faced. He sits upon one of these Ma'aglyphs. These two ladies stand upon this glyph, indicating that they're aligned with truth. You notice, by the way, they're also holding two snakes with the feathers on their head. These two snakes are one of the ancient depictions of what we now call the caduceus, with the two snakes and the medical symbol of our subtle nervous system. But if you notice on their heads, they have feathers. And these feathers are actually the sign of the goddess named Ma'at, which is just Ma'a with the feminine ending, the letter T. So she is Ma'a personified. This goddess, she's the goddess of unchanging truth, balance, harmonious proportion, honesty, righteousness, moral uprightness, justice, and the beautiful order of creation. Say, well, musicians, artists, architects, and judges actually were priests of Ma'at, and they wore this feather symbol on a necklace. Well, maybe we can understand why musicians and artists and architects might be interested in proper proportion. Musicians, of course, because the proportions of the ratio of a vibrating musical string determines the music that comes out of it. We see Ma'at symbol on top of this instrument, and we see it on top of this scale here to indicate proper balance. But judges also had to understand proportion, because injustice was considered harmony broken, and judges had to understand mathematics and music to bring about justice, which was considered harmony restored. And so some of the rules involve this grid system that were used to proportion their arts, crafts, architecture. Unwritten rules, they didn't write about it. I'm sure it was all taught in the temples. But for example, if you were going to depict somebody to the crown of their head, not to the crown, excuse me, to the brow, would be indicated by 18 units. And sometimes you'd see the crown of the head at 19, sometimes it'd be a crown itself. But there was pretty much general rules, and it's accepted by the academics, Egyptologists, that they designed their art this way, everything fit in a grid. But there's really more to it than the grid. In my opinion, the grid was the last item appearing. What they would do, the priests would design their art through proportions that I'll show you in a moment, and then they would lay the grid over it so that any craftsperson could just copy this image without having to understand the original proportions that went into it. So, for example, we see here an artist's model of a lion, which is in the Met Museum in New York that Walter recently visited. Notice that one side is completed and one side isn't. Look at the paws. You see, this was an artist's model. They showed you how it all should be made. In fact, you can see this grid on the side incised into the limestone, and there are a few lines that you might be able to notice here for the carving. So they used this grid for proportioning. And you can see another place, these stars painted on the ceiling of the tomb of Horemheb in the New Kingdom, the 18th dynasty, known for beautiful art. You can really tell the grid is there, and in fact, if you look more closely, you see the grid in greater detail with these five-pointed stars. Now, the five-pointed star is very, very important in ancient Egypt. The word for the five-pointed star was sba. Not only did it mean a star, but it also meant a door, and it also meant teach, or a teaching. That's a very interesting trinity of ideas: star, door, and teach. So I'd like to take a moment, a little while, to look at the place of this star in Egyptian art. It appears widely in their art and symbolism, and it occurs in a variety of types. In other words, here's a five-pointed star with a circle in it. Here are other ones that are drawn almost like Chinese characters. Another one with a circle in it, one without a circle in it. Now, this idea of fiveness, pentagonal symmetry, appears in nature. And when you see it in five-petaled flowers, starfish, and elsewhere, it indicates elegant, balanced growth, an unfolding, a balanced unfolding. But the pentagram star has very remarkable geometric abilities, shall we say, because it's based on the so-called golden ratio. And what that ratio really indicates, it's really quite simple, is that a whole line, well, you can put it more simply. Your forearm, the cubit, the whole is to the larger part, elbow to wrist, in the same proportion that the elbow to wrist is to the hand. In other words, it keeps a unified proportion in diverse situations. There's a unity underlying this diversity. And so every red to green line here is in that ratio, long to short. So whichever way the star, when the star is drawn, it always cuts itself into this ratio. And it exists throughout our bodies. The relationship of the consecutive bones in our finger and into our hand even are in this ratio and on average. And in fact, if another thing our third grade teacher didn't tell us is that each two bones add together to make the next bone. Each two bones add together to make the next bone. You can see it in your own body. It's a beautiful, accumulative, self-reinforcing geometry. It's quite lovely. And so what this does is allow this pentagram to reproduce itself in different sizes, fractal-like. And in fact, it'll fit everywhere, balanced. In other words, another pentagram will fit in every little space you see. It reproduces itself over and over and over again. The idea of fertility and generation right here, and regeneration. So we see this throughout the plant world. When you see five-petaled flowers on a bush, it's because that all these different flowers can exist in different stages of growth, different sizes, different weights, all at the same time and remain perfectly balanced. And so the Egyptians, who were known as great observers of nature, must have seen fiveness, this birth, rebirth, generation, regeneration. Here we see it if you cut an apple across the equator, or a pear, many fruits. You'll see this package of five-petaled package of seeds, the essence of generation and birth. Or these starfish, well known for their regenerative properties. You know, if an arm is lost, the body will grow a new arm. And it turns out that if a little bit of this circle, perhaps you see this circle, all these lines show you its nervous system. If a little piece of this circle becomes incorporated with the missing arm, not only will the body grow a new arm, the arm will grow a whole new body. Much to the consternation of early oyster farmers who would find starfish and just rip them up. And they'd realize, like the Sorcerer's Apprentice, they'd proliferate. Flowers are well known for regeneration, grafting, and so forth. A pomegranate peeled away, you can find the fiveness throughout the plant world. Lettuce, just look at the bottom of lettuce, or broccoli, cauliflower. I tell my students that one of the best math museums in the world is in your local produce section. Here's a bunch of celery, which I cut and scanned, and you can see it's the fiveness, and there's a spiraling to it as well. Well, the Egyptians used this five-pointed star as a very particular glyph. It was used as a symbol of the so-called Duat. The Duat meaning the underworld or netherworld realm of Usir, or aka to the Greeks Osiris, through which the sun sets in the west, goes underground, so to speak, through this netherworld, has struggles and battles, and then is reborn at dawn. And you can see here the baboons in deep worship. Here's the keper, the beetle, which a hieroglyph which means to exist, to become, to transform, and it's raising the star of the glyph of the Duat up to the sunrise to be born. And there are also 5 rays on these coming from the sun, and they're flower petals. I give sunlight as flower petals coming onto the earth. It's a lovely idea. Well, how is it used? Something like this in a practical manner. We have this necklace of faience beads from Dynasty 18, 1300s BC, from the reign of Akhenaten. There are 5 rings of beads. That should be something of a clue. But also notice the 5, notice that there are central color groups. It goes yellow, green, red, blue, yellow, green, red, blue, and so on. How many yellows? 1, 2, 3, 4, 5. So what does that do for us? Well, if we put a circle around the entire necklace and put a 5-pointed star in it, and a circle joining the points of the crossings of the intersection at the golden ratio, a circle there, which can be nowhere else, it's fixed, is the relationship of the outer circle to the inner circle. It was very important to build things, to make things in a proper symbolic manner. Well, and by the way, there are the intersections occur right at these yellow sets of beads. But even more so, what about the sizes of the beads themselves? You'll notice that there are different lengths of beads here. Well, first of all, a simple pentagon drawn in that, and a circle within that gives us the outermost ring of beads, and a star put there at its crossings gives us a couple of more rings of beads, and one final star at the bottom, and at its crossings gives us the final sets of beads. So this was a symbolic design used for their magical purposes, somehow symbolizing this underworld as Duat. And so this kind of symmetry, pentagonal symmetry, really all geometric symmetry, it provides a scheme for harmonizing the parts into a coherent, very pleasant-looking wholeness. The crossings, the lengths, the golden ratio, the long and the short, also occur in the so-called golden rectangle. The long to the short makes this particular rectangle. This is the one you can see. Here's half of it, made by your arms. And it's sometimes known as a rectangle of whirling squares because if you cut a square out from it, it always leaves a golden rectangle. It regenerates. It generates and regenerates. It does not change. No matter how many times we make this, cut a square out of a golden rectangle, it always leaves a golden rectangle. There's the idea of generation right there, and regeneration. And I put it a simple white arc in each of these squares, and you can see as it goes around and around, it always leaves a golden rectangle, and it's making the spiral that's so common in nature. So common in nature, because when you see any spiral like this, you know that nature is balancing. It's a dynamic balance. It's not like a triangle, a static balance. It's a dynamic balance. And not only that, but the parts model the whole, just like the golden rectangle was always left, and it models the original golden rectangle there. For example, in this fern, you can see the entire fern is a spiral, and it's made of these little spirals, which are made of littler spirals, and it's always the same spiral in different sizes. So the object can grow and maintain its balance no matter what its size is, no matter what weight it is. And we have the same idea here in our galaxy with the entire, this is not our galaxy, but ours is similar with this kind of spiral, and every one of those dots is a star with a whirlpool of planets around it, and sometimes the planets have a whirlpool of moons around it. So it's the same idea, the fractal idea, over and over again. We see it in whirlpools, seashells. This is the hair on top of a baby's head. From what I understand, I haven't really done any kind of survey, but from what I understand, the direction of the spiral is a determination or shows whether the child is left-handed predominantly or right-handed, whether it spins this way or that way. And it even appears to a certain extent on this Egyptian crown. And User, or Osiris, was the Egyptian deity of regeneration, rebirth, resurrection. symbolized by the green color of vegetation of his face. He was dead and brought back to life, and so it makes perfect sense to use this geometry to shape art that involves death, birth, death, and resurrection. And the way it works is simply, when the golden rectangle is horizontal, it might be considered as Osiris in his sarcophagus. A square gets on top of it, and lo and behold, we now have the golden rectangle, same proportions, but it's now upright. It's been resurrected. And so it makes sense to use it in art involving Osiris and others. Very often you'll see in Egyptian art, architecture, images framed in rectangles. And very, very often those rectangles are golden rectangles. Not difficult to find, and the combinations as well. Here we have the goddess Neptis, or Nedchet, which means lady of the house. Notice the position of her arms. I've seen this position in other works of Egyptian art. See this angle they slant at? Well, is it a coincidence that the angle is at the pentagonal angles? Also, the rectangle which, by the way, puts her name, Nebchet, in the center of this five-pointed star. And the rectangle that she's standing in is essentially two golden rectangles. Now, why they chose two or one or three, we'd have to speak to a priest to know about that. And you can take this a little further. If we lop out a square from the top of that, you can see it leaves a golden rectangle. And simply quartering the square shows us more of the scheme, the top of her head, and the alignment with her name. Here we have some painted stars and lamps from the tomb of Tutmosis III, 18th dynasty also. You see here a star and a lamp offering. And guess what? The boxes are golden rectangles. How the Egyptologists can't find this, I have no idea. All I have to do is measure, or don't even have to use a ruler. You can use a compass to find this. And if you lop out a square from that, you'll see it centers the star in the square, just like on the tomb ceiling, and it leaves a small golden rectangle which defines the height of the flames. Here is called the hearing ear stela of Bai, 19th dynasty. Ordinary citizens, if that's the right term, were not allowed into the temples. It's not like modern churches and so forth. But if you wanted to speak to your favorite deity, you could go around back of the temple on the other side of the most sacred room, and there would be a stela like this, and you see there are ears, and you can talk to the ear. And there's a color symbolism. Who are these deities? Who are these particular deities? Well, if you know that blacks, which is a symbol of transformation and so forth, relates to Amun, the hidden, yellow or golden Ra, the sun, green, of course, Osiris. It turns out that the entire stela, like many others, I've analyzed images of hundreds of these, good images of hundreds of these, and really, I mean, virtually every one is built on either golden ratio or a combination of golden ratios and squares. Well, the whole is a golden ratio, and perhaps you can already see what will happen if we lop out a square from the bottom. Boom, right there. It gives us the proportioning between the square and the golden rectangle. Squared around the world is generally a symbol of earthliness, the four corners of the globe, so to speak. And the golden rectangle indicates a sacred space up above. And I could have spent more time with you showing you how this all subdivides into squares and golden rectangles to indicate every bit of this. Here we have something quite old from the pre-dynastic time, the so-called stela of the Serpent King. Now, I'm not going to analyze the entirety of the falcon standing on a rectangle with a snake and some architectural design below it, but we'll just look at that architectural design, or the rectangle. It's called a serek. It's a stylized palace. Nice architecture from those days. And it turns out, of course, you're probably getting good at looking at this, the whole is a golden rectangle. By the way, notice, this is some of the subtlety of Egyptian art. Notice that it's tilted a little bit towards the left, which is done so that it gives a slight visual feel of the weight of the falcon. Very, very subtle. You would hardly notice it. It's all a golden rectangle, and guess what? We'll lop a square out. Ta-da! No big mystery here. That the square defines the palace facade. In fact, if I had made a square off of this end of the serpent, this a diagonal of the square would indicate perfectly the tail angle. And in fact, without going too far into it, we can see that reproducing that particular golden rectangle on the side shows us the proportions, the beginning of the proportions of the palace facade. And by lopping out squares and golden rectangles, you can get every single line in that. Here, the deceased, who is called an Osiris, lies in his sarcophagus, and you can see that the rectangle below the lid is a golden rectangle. If we lop out a square from that, we can see that it clearly defines the earthly sphere where the mourner is mourning, her knees, elbow, and so forth, defines the edge of the headdress. And quartering the square, very simple, not esoteric geometry here. Quartering the square shows us how these design rules are coming into play. And I could have taken this further too to show you more of it. Here we have a sarcophagus, originally intended for Hatshepsut, but for some reason was recut for her father, Tutmosis I, 18th dynasty again. And all of these were designed very carefully with golden rectangles and squares. You see this lovely pattern, a central golden rectangle and two flanking golden rectangles, or here a pattern of 3 and 1, 3 and 2, 3 and 1, 3, and also the side of the whole business. Very simple. You don't have to get all complicated with esoteric, difficult geometry. The Egyptians were really quite simple with this. And there are many. I could have gone through many of the sarcophagi and show you the same kind of pattern, but with variations. And by the way, with the work of John Neal in London, along with the work of John Michel, you can actually understand this in terms of the measures, the actual measures to many decimal places of their so-called foot and cubit, and see how these were designed. A sarcophagus lid. Old Kingdom, pretty old stuff, from the Giza Cemetery, white limestone. There's a panther skin on here with two edges. Well, it turns out, well, here's how we can do it. Just simply starting with a square and the two semi-diagonals here, to that end and this end, and just swing the compass, and it shows you where the two ends of the entire sarcophagus should be. This is called a square root of 5 rectangle, because the ratio of the long side to the short side is about 2.236 to 1, known as the square root of 5, a very important symbol, 5 indicating life and regeneration. Well, there's more to it. We could actually rearrange this so that we can see that the panther design is a golden rectangle itself, and the two ends are these squares flanked by these golden rectangles. It's called a phi-cubed rectangle. Here's a cabinet, the drawer of a cabinet of Tutankhamun. The whole cabinet is a golden rectangle. But how was this drawer designed? Well, very simply, put a square there. The two semi-diagonals, they indicate the size of the proper proportioned harmonious knob. And if we swing those around, we get the exact same square root of 5 rectangle. They used it quite often, this particular rectangle. One of the more interesting examples of this square root of 5 rectangle comes from the tomb of Tewazret and Setnakht. The 20th dynasty, this is a final scene from the Book of Caverns. We can see that the sun, the Keper, the scarab, is pushing the sun up, it's red, so it's still underground to be born. And I wondered about these triangles. Are there any particular triangles? Well, it turns out that the whole scene can be understood as upper and lower areas, and even furthermore, that it's actually it can be understood as four of the same exact rectangle in different sizes. And what are these rectangles? Ta-da, root 5 rectangles. You notice a square perfectly surrounds the scene of the rising sun. And these are gates, actually. They're opened right now. And you can see they fit in golden rectangles, and that they actually fall upon the diagonal of the golden rectangles. So they're indicating it's some kind of a sacred space. And I could have actually taken this further, and you would see there's a golden rectangle right here, as there is on the sides. And I could have lopped out a square from each of these sides. You see here would encompass the wings. After you see this, you should be pretty good at analyzing Egyptian art. And this really interested me. This cabinet from Tutankhamun. How do we account for the dimensions of this rectangle? It's too tall to be a square. One golden rectangle encompasses that picture with the knob. And so if we lop a square out of the bottom of that, it shows us how large the knob should be to fit into this harmonious visual and proportioning. In fact, what I did is I lopped out a square from the side of the golden rectangle and moved it in the center, and took the remaining golden rectangle, quartered it, moved it to the side, so you can see more of the proportioning of this little scene. But nevertheless, how does that line come about? Well, not difficult. All we have to do is quarter the golden rectangle. And can you see where it's going? Just lop out a square from the top of those. Very simple rules. They're not, when I see people get so complicated about Egyptian art, I wonder, because it wasn't complicated, at least as far as I see, and I hope that I'm showing you. So it's actually two of these vertical square to 5 rectangles. I left out the middle square. This root 5 rectangle is the horizontal and the vertical together, the death and resurrection all in one proportion. In fact, this watering the mummy, this filled with wheat, tells us life emerges from death, fertility and resurrection at work. It turns out that the entire scene begins as 2 golden rectangles framing it. And what they did is they would lop out a square and lop out other squares and so on and so forth. I'm not going to go into each of the steps, but I'll show you the end result of it. It's really quite simple and quite lovely. There's this nice line pattern at the bottom, very common. Each of these triple sets of symbols, the uwas, meaning power and life, and was, each fits perfectly in a square, and we see that in other forms of Egyptian art where these 3 come together. And 1, 2, 3, 4, 5 golden rectangles, and another simple proportioning gives us the whole scene. It was very, very important to proportion their art properly so that the so-called magic would work. Well, in order to understand much of Egyptian art, as maybe you're guessing by already, you only have to understand a couple of ideas with this golden rectangle business. That any golden rectangle can be divided into a square plus a smaller golden rectangle, and that the square can be divided into a large golden rectangle, a small golden rectangle, and a square. And if I lop out a square from this end, we get this bottom scene. The Egyptians very, very much like mirror symmetry. It's very important. So being able to subdivide a square in this manner is all you really need to know to understand a great, great deal of Egyptian art, crafts, and architecture. Here, a simple drawing, a modern drawing actually, very carefully done, I might add. I think this is by Lucy Lamy, of a temple pylon, the gate into a temple. Well, it turns out the whole is a square, and if we subdivide the square just in the simplest manner of a golden rectangle and 2 golden rectangles here and 2 squares, you can see how the divisioning is starting to begin. And we can take it further, and we see that the golden rectangle at the bottom, the large one, resolves into 2 golden rectangles and a a square root of, well, actually, this is a phi squared, the golden ratio squared rectangle here. One big example, I wanted to show you how this works, just to show you a little bit more detail than these very simplistic images, is this pectoral, meaning it was jewelry that was worn on the pectoral muscles on the chest of Tutankhamun. And it's the deities. Here's our Nebtchet again, and Aset, known as Isis, excuse me. In fact, here are their names written in gold. And in the center is what's called the Jed pillar, identified as the spinal column of Osiris, which starts off horizontally and then gets brought up to be resurrected. At the top of it, we have a sun in this color. This ruddy, reddish color is the color of the sun of the so-called underworld, Duat. The yellow sun is a symbol of the earthly sky. In fact, that's the key to understanding why in Egyptian art, the coloration of the skin of males and females is also symbolic, unless there's a particular special case where, for example, they have blue skin here. Males are generally depicted with this ruddy, brownish, reddish color, and females with a yellow color skin. Just look through Egyptian art, you'll see that it's the colors of the suns of the underworld and the upper world. And so the Jed pillar is arisen, and the sun is going to emerge up through the dawn. Well, it turns out that the whole image can be understood as a square plus this so-called phi squared rectangle. In other words, phi, the golden ratio, this 1.618 value, has a very interesting property. If you square it, in other words, you multiply 1.6180339 times itself, it's simply the same as adding 1 to it. Very, very interesting mathematical property. But what we have here is a square and this combination of golden rectangle and square on the side. You can start to see some of the proportioning coming into play here. And if we divide the square, as I indicated before, into a golden rectangle and another phi squared rectangle, I think we can see how they began this, with the two deities on the sides in their own combination square golden rectangle. And in the center, we have this sacred scene of the upright Jed pillar and the rising sun. You can see how again, how the proportioning is happening here. Well, what do we do with this? Well, how about we just lop out a square from that center, and you can start to see some important parts of the image are coming into play. And now what I'm going to do is I'm going to divide each of these three squares, this one, and this one, in the way I just showed you, as a large golden rectangle and the phi squared rectangle too. In the center, the golden rectangle will be below, and in the side, the golden rectangles will be above. Very simple proportioning, not complicated, is how they design these. I think you can see that we're starting to understand why this top of the pectoral comes right to there. We can also start to see some of the extremes of the sides of the framing of all this. And I might add that to the Egyptians, even the negative or so-called empty space must be included in the harmony of the whole. You can't exclude it just because it's not visible. It's very, very important. And you can see up here that we have a square, golden rectangle square, and flanked by two golden rectangles. Take a little further, what I've done is I've put semi-diagonals, and you can see how I swung down, and it gives us this center golden rectangle, and it's going to give us ones on the side. And just as an aside, I wanted to point out that the students of the Egyptians, known to us as the Greeks, who learned all of this from the Egyptians, used it in their Parthenon, for example, designed by the great Phidias. It's well known that the Parthenon itself fits in a nice golden rectangle when completed. And right up here at this level are these called metopes and triglyphs, mythological scenes separated by a rectangle. Well, it's the same geometry. Those centers are squares. The semi-diagonals swung down very clearly give you the golden rectangles on the sides and in between them. Not only that, in the Parthenon, lopped out a square, and in that square lopped out a golden rectangle, and you can start to see how the proportioning of the great Parthenon was made. And so we come back to the Egyptian, continue this just simple swinging of a compass, takes us right to the ends and gives us 7 spaces. Square, golden rectangle, square, golden rectangle, square, golden rectangle, square. And we can take this a little further. What I did is for example, taken those squares, simply divided it into a golden rectangle on top and the phi squared below, took the golden rectangle, lopped out a square, leaves a golden rectangle, and we can see the proportioning of this top piece coming into play at these divisions. In fact, we can even explain this little bit up here a little more further by just simply repeating the same cut. And it shows us the space above, the space below with these feathers and so forth. And we can even go down to those little pieces here. What I did here was simply continue this square downward, and it gives us 1, 2, 3, 4, 5 of them. Leaves a little gap down here of where we see this gold bar at the bottom, and it's simply this lovely pattern of squares and golden rectangles going across. I also lopped out a square from in the center here. In fact, let's see, what did I do here? Well, just simply took it further again with the lopped out a square from this golden rectangle. You see it's giving us more of this. The deities are in this double square, and I see this really quite often, the deities within the double square. And taking it much further, without going through all the steps, you can see that there's a more complete armature here. In other words, this square quartered gives us these little pieces, and there's alignments and showing us where the serpents are on the crowns, and more details of these scenes. So there is a kind of a grid at use in play here, but it's much more than the simplicity shown to us by the Egyptologists that it's all based on the graph paper type grid. There's a very interesting golden ratio geometry going on in the background that the priests knew about, but the artisans who carved it into the sides of mountains and made the imagery didn't necessarily understand. And so in our final image, we come near the sun's journey through the underworld, the Duat. We see down here Shu, the deity of air and space, raises the boat of the sun up towards sunrise. He has a spiraling Osiris. The Keper pushing the sun upward and the boat of the sun. Notice this rectangle, and why nobody examined it to determine that it's a golden rectangle, which indicates that it's a sacred space. So I hope you're either convinced or more open-minded. Now, by the way, I'm a little off down here. I should have shifted this up just a teeny bit. My lines are a little off, but believe me, they're standing on it. And I hope that you're somewhat convinced, at least, that this particular rectangle, which is not written about anywhere in Egyptian papyri, but if you look at the art, if you know how to look, without difficulty, I'm not fudging it, I'm not forcing it, it's pretty clear. So I hope you are somewhat convinced of this. And so we now see the Nile sun emerges from the Duat, just as we now emerge from my presentation. And, well, I thank you very much, and I appreciate your attention. Thank you.
We have a 15-minute break.
15-minute break.